Okay, so we're getting to the good stuff. Lightning and thunder. So, I don't know if you noticed this, but we have a hockey team called the Lightning. Huh, I wonder why that is. Well, let's look at lightning. So, lightning strokes. It's actually the second largest storm-related death in the US. First is flooding, which you may or may not know because this is meteorology, not earth science, but lightning is the second largest. And there's actually 60 deaths reported per year, but they think it's actually more like 100, okay? Because they think some deaths are not actually reported. Some deaths, they believe, come after people get struck by lightning. So they get struck by lightning, they're fine, or fine-ish, and then they recover, they're fine, but then they die later on. Could be weeks, months, years later. But it's the lightning that actually caused the death. Now, injuries. There's over 1,000 injuries per year. So you hear a lot about, oh, people get struck by lightning and they died, right? So, oh, you get struck by lightning, you die. Not really, right? If there's only 100 deaths per year, then, but 1,000 or more injuries per year, that means only 10% chance that you are going to die after a lightning strike. I actually know someone that got struck by lightning twice. She was out doing field work in the Everglades, and the storm was coming, so we're rushing to put the stuff away, and she's got this equipment she's carrying, so she starts carrying back this big metal pole in the middle of the Everglades, and got hit by lightning. Her arm and her hand was numb for like a month, and then she was out in the just off the coast of Miami in a boat, and the storm was coming, so they were coming back in again, equipment, all that stuff, and she got struck again, and her arm was fine this time. Her hand was tingling for about a week, so I was like, maybe she's building up a tolerance. I don't know, poor girl. Anyways, so if you get struck by lightning, not necessarily you will die. Okay, so things not to do when there is lightning around. Be in an open area, like a sports field. So this is why they should, or I think they do, cancel or postpone games while there is a lightning storm or thunderstorm. Don't go under trees to keep dry. Right? It's kind of actually sad. You'll see cows doing this, and I've heard stories from farmers where they all go under the tree to keep dry, the tree gets hit by lightning, all the cows around it die. That stinks for the cow and the farmer. So don't do that. Water-related activities. Oh, like swimming, boating, fishing, don't be in the water, right? Golfing. Again, wide open field. Farm or construction vehicles, because these guys have the open cockpits, so it's not as protected as a car is. Okay, this one is just stupid. Corded telephone. Does anyone know what a corded telephone is? It's a telephone with an actual cord attached to it, and it's not cordless, so you can't just walk around. It's got a landline. And this is just if you know what one of those are, don't be using it, okay? Golfing. Again, so golfing in the open, number 4 here, or golfing while you hide under trees. Okay, so golfing is just bad. Plus, think about golfing. You're either in an open area or you're hiding under a tree, right? And what are you holding to golf? A big metal stick. Just saying, not too smart. And then using radios or radio equipment. So if you're in a thunderstorm and you want to change the radio station, just wait, just put up with the commercials, okay? So there's 2 different types of lightning. There's sheet lightning and cloud to ground lightning. So cloud to ground is the one that you usually are like, oh wow, look at that, right? It hits the ground or something on the ground. That's actually only 20% of all lightning hits the ground. Sheet lightning the one where it goes cloud to cloud, that's actually the most common, which is strange because when you see it, you're like, oh, wow. Like if you were not, I mean, when you see the lightning inside the cloud, you're like, wow, that's really cool. The cloud lights up, but it doesn't hit the ground. You're like, wow, that's really cool. But that's actually more common than the lightning hitting the ground. Kind of a disappointment because you're always like, oh, it's very pretty, and then, but it's more common. Interesting. Okay, so what causes lightning? I'm just going to go real basic here. There's a positive charge and a negative charge, and everything in nature likes to be in equilibrium, right? So they don't like being all negative, they don't like being all positive. So what actually happens is the negative ions kind of come down to the ground, and the positive ions on the ground go up. And so it's basically a neutralization. So you can see it in this picture here. It's a neutralization or an equilibrium of the charge. So you have the negatives going to the positives. And in this picture, you can see why lightning goes up and down, or cloud to cloud and cloud to ground, because it's all negative here, positive up here, so it will equilibrate this, or all negative here, all positive here, it will equilibrate this. Alright, so lightning strokes, it's actually not one strike, it's a whole bunch. It's usually at least 4. Now you can see here, 1, 2, 3, 4, 5, 6, 7, 8. Right here it's 8. So it's actually little tiny ones, but your eyes can't see it that quickly, so it sees it as one big one. Sometimes you will see a flickering in that big one, and you're looking at the actual strokes. The thing that we see is actually called the flash. Okay. It lasts only like a fraction of a second, a few tenths of a second, a fraction of a second, but this is what we see. And so these are the multiple strokes that come together to make the flash. There's different parts of a stroke. There is the leader. This is the part where the air is ionized here. Okay. Then there's a step leader. This is the part that's almost visible, not quite, little short bursts to help get the ions down the path. And then the return stroke. So this is actually the stroke going from the ground to the cloud, and this is the part we see. And then there's the dart leader. The dart leader basically reionizes the air, so the leader and the dart leader are essentially the same thing, it's just happening at the beginning and the end of the lightning. Okay, thunder. Let me explain it first. Thunder is the result of the air heating very quickly. Okay, so you've got the air, what? Let's go with Florida temperatures, 85 degrees. Okay, 85-degree air outside, lightning hits. Well, what happens with the lightning? The lightning is electricity going right through the air. Really, really hot electricity. So it takes it from 85 degrees to 33,000 degrees in a fraction of a second, right? So that is a big temperature change, little tiny time. So because of that, the air actually expands, and expands quite explosively. And when you think of explosion, you think of boom, right? And so that's what the thunder is. The thunder is the fact that the air is heated so quickly and so much that you get the boom. And before we get into all these other numbers, let me just tell you, I was at Disney once, and you know the Astro Orbiter at Magic Kingdom? It's like the little spaceships that go around. It's on the top of the building. Right? Well, I actually know someone who worked there many, many years ago. Yes, he's much older than me, but many, many years ago, he worked there, and he was in charge of Tomorrowland and the rides and blah blah blah. And so a thunderstorm was coming. So he's like, okay, you have to close down everything, especially the Astro Orbiter, because at the top of it, it's actually a lightning rod, which keeps you safe. So it hits the lightning is supposed to hit the rod, and that's just because the rod is the highest point. So and it's metal, so it'll hit the rod, and the rod directs the energy of the electricity down through the rod, and then in Disney it actually goes underground and disperses the charge. So it's actually it's pretty safe, but you don't want to be like on the ride, right? So you gotta shut down all the rides. So he's shutting down all the rides, and he goes to check the Astro Orbiter, and everyone's like, yeah, it's all shut, and he goes up to check it. He's checking it. Lightning hits the lightning rod, not him, and blows him back into the elevator, knocks him unconscious, and they actually have to come and find him, so like he never came down. So they had to go up and find him, and then they brought him to first aid, and I mean he was fine. He actually went back to work after like half an hour or so. Anyway, so I know someone that got essentially hit by lightning on that ride, right? So I'm on that ride. Well, I'm not on. I rode the elevator. The clouds are looking right. I got me and my husband, my two little girls, one of which was just like a little baby, like one. And so I'm standing there waiting for our ride. Rain is pouring. I'm going, I don't really want to do this. And all of a sudden I hear thunder. And I'm like, oh, okay, I'm done. Like where's the chicken out door? I am leaving, and I am taking my kids and my husband with me. And my poor 5-year-old at the time, she was like, no, Mommy, I want to ride. I want to ride. I'm like, no, you don't. No, we are not riding. So I go to the person working the elevators. I'm like, get me down. And she's like, oh, when the elevator comes up. I'm like, no, get me down. And she's like, no, everything's fine. It's just rain. And I said, didn't you hear that thunder? She goes, yeah, but that's just thunder. There's no lightning. We'll get called when there's lightning. I wish I were telling you this in person because I wish you could see my face. It's just like, I'm sorry, did you say that just because you heard thunder, it doesn't mean there's lightning? I think someone might need to take my class. Because lightning comes, it literally explodes the air. And that is what thunder is. So you cannot have thunder without lightning. And so I insist that she gets me down, right? So after, a couple seconds of me just blankly staring at her, I insist she gets us down. So we get in the elevator, and she's like, oh, like the elevator comes up, we get in the elevator, and I'm just like, okay, at least I'm somewhat safe here. And then I'm waiting to go down because I really want to get out of here. And I'm like, come on, close the doors, let's go, I want to get out. And all of a sudden, what did she get on her little walkie-talkie? What? Oh, a message that they need to shut down the Astro Orbiter. And so all of a sudden, everyone's coming into the elevator. Obviously, this was pre-COVID. And I'm just like, yeah, That's right. Okay, so bottom line is please understand lightning, then thunder, right? The lightning scores at the hockey game, we all applaud in thunder, right? Lightning, then thunder. Got it? All right. So how do you hear the thunder? Well, light travels a lot faster than sound. If you want to learn more, go to physics or take my astronomy class. But light travels a lot faster than sound waves. So you see the lightning, you hear the thunder after. Again, lightning, thunder. Right? So there's usually 5 seconds means it took about 1 mile to travel. So it traveled 1 mile in 5 seconds. Okay. Now, if the lightning is more than 20 kilometers away, thunder is not heard. So if it's too far, you can't actually hear the thunder. All right. There is an awesome documentary I put in one of your assignments. Please, 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 please watch this documentary. I mean, this is my favorite documentary. Well, this and sinkholes. So, but that's shown in my earth science class. And if you want to really get depressed and scared about where we live, take earth science and watch the sinkholes documentary. However, the lightning is really, really cool because it's about people who mostly survive. So, kind of neat.